for building ontology, we need to use the Protégé tool. So Protégé tool is available, is a free source table, open source table. You can download it as per your operating system of the system. Whether you can download from here. It is like Protégé download for Windows or for Linux system. For Mac you can download it. It's very simple to install. It's just it is already in my laptop, so I'm just showing you. Once you download, it will be downloaded in the form of zipped file. You can unzip it, and you can, it is already there. So you just have to double click here. You will get one icon here, and there some kind of UI. Without this it will be getting displayed. I have already built the healthcare ontology that we are going to build. So in the left side you can see this is already present. So all these what is the classes, data properties, annotation properties, everything we are going to build it. So before starting how to build it, please keep this ready in your system so that you can build the ontology along with me. So now come back to some rules. Before building the ontology, we need to understand, we need to remember, we need to keep some rules in our mind while building this ontology. So the first one is that the is a or kind of rule. So this is about is a kind of means while we are declaring, while we are deriving the class for our domain. So it means that ensuring the class hierarchy is correct. Rule 1 means the is a or the kind of rule. A subclass of a class represents a concept that is a kind of the concept that the superclass represents, right? So if class A is a superclass of B, every instance of B must necessarily also be an instance of class A. So in our healthcare examples, so cardiologist is a subclass of doctor because every cardiologist is necessarily a doctor. So I'm just showing you here, but again we have to we have to build all this. So when I say this is the classes, so here I have 6 person. Person comes different kind of person. Inside this doctor I am having cardiologist. So what you can say, the root is owl colon thing. Inside that all the classes will be defined. Then the person can be any kind of administrator, insurance, pharmacist, receptionist, doctor, technician. Then doctor can be of different kind of departments, belongs to different kind of specializations. So he can be pediatrician, physician, neurologist, cardiologist. So it's a kind of. So here doctor is the superclass and cardiologist is the subclass. So it means the cardiologist must be a doctor. So now coming back to the second rule, singular versus plural mistake. So what happens now? Never make a plural class that patients. A superclass of a singular class. So here it is like if I can say like that, there are so many person types are defined. So can I make this colon persons? No. It should be only singular. So never make a plural class a superclass of a singular class. A single instance is not a kind of the plural collection. Pick one convention and stay consistent, right? The next one is about transitivity of subclass relations. So if B is a subclass of A and C is a subclass of B, then C is a subclass of A. So in our systems, how is it? Cardiologist is a subclass of doctor and doctor is a subclass of person. That means cardiologist is a subclass of person, and this is called transitivity rule. So make adhere to the. Next is the rule 4, that classes are concepts, not names. So classes represent concepts in the domain and not the words that denote these concepts. Renaming a classes does not change what it represents, right? So if we go to this, all these are like admission. It's not like what kind of admission. Allergy, it's not like skin allergy or some different kinds of allergy. These are not names, these are some concepts. So here we have to make these classes are the concepts. So next is that no duplicate classes for synonyms. So if you go, the next one is about no duplicate classes for synonym. Classes, synonyms for the same concept do not represent different classes. For examples, do not create both physicians and doctor as separate classes. So here physicians means doctor. Separate classes if they mean the same thing in the model. Just pick one and make consistent, right? And here the doctor is a type of physician, but it's not again doctor and physician are two separate classes. It's a subclass we have defined here, right? And the next one is that avoid cycle. 6 rule. A cycle, A is a subclass of B and B is a subclass of A, and effectively declares A and B are equivalent, almost always a modeling error. So avoid it. The next one is about rule 7. Siblings must be at the same level of generality. So all the siblings in the hierarchy, all the siblings must be at the same level of generality. For example, doctor and cardiologist should not both be the direct children of person. Cardiologist is more specific and belongs to doctor. The next one, too few subclasses, a warning sign. If a class has only one direct subclass, there may be a modeling problem or the ontology is not complete. We have to think how granular level we can go. Each minute information we have to capture in our ontology system. The next one is about too many subclasses, then split them. If there are more than you can say more than 20 or 20 subclasses, 20-30 subclasses for a given class, then additional intermediate categories may be necessary. For examples like this person, a doctor, and there it can come like the different kinds of doctors are coming. Okay, if doctor ever grew to 20 plus specialist, then you would group them under intermediate categories like surgical specialist, medical specialist, like that, right? You can extend this ontology, what we are going to build in this session, to the next level. Next one is about when to introduce a new class. The new properties or the restrictions or the relationship test. So subclass of a class usually have additional properties that the subclass does not have. And for examples, this person is having some kind of properties. But if you say like that, it's difficult to capture all the properties with the person. Some properties might be specific to doctor. So in that case, we have to define that no, doctor will be a new subclass of that one. So for examples, if cardiologist might have a certified in cardiac procedures property that plain doctor does not have, then that justifies some kind of subclass. Next rule is about 11. Terminologies hierarchies are exempt. So classes in terminologies hierarchies do not have to introduce some new properties. For examples, a disease classification hierarchy like ICD course can be some kind of, if you can say, this is the treatment, right? So here different kind of treatments have come. So if you go for some kind of disease classification hierarchy like ICD course, if you have seen ICD course like ICD 9 or 10 can be purely organizational specific with no new slurs per level, then it exists to aid navigation and consistent terminologies use. The next rule is about create a class when the distinction drives other restrictions. That means if the concepts with different slot values becomes restrictions for different slots in other classes, then we should create a new class for the distinctions. Next is that create a class when the distinction is conceptually important. For example, doctor speciality was made a class, that is like cardiologist, surgeon, etc., rather than just a specialization string value, because speciality drives different relationships in the hospital model. The next one is about class membership should be stable. For example, admitted patient versus discharged patients are separate classes would be risky. A patient status changes constantly. Better to model status as a property. So admission status on patient, not as changing class membership. So we can make those as some kind of data property. Instance or the class related. So instances are most specific things. For example, patient John, Dr. Smith, prescription 001 are instances. You don't need further layer of specificity below them. Natural hierarchies must be classes, not instances. So if department needed subcategorizations, for examples here, where is we are having department. So if a department needs subcategorization, it must be a class, not an instance, because only classes can have subclasses. Then next one is about do not model every possible property. The ontology should not contain all the possible information about the domain. So you do not need to specialize more than you need for our applications. Next one is declare disjointness where it holds. So here some examples is like some patient, doctor, then nurse, technician, pharmacist, then receptionist, administrator, all pairwise disjoint. If someone is accidentally typed as both patient and doctor, the reasoner flags an inconsistency. So we should not write disjointness when it holds. Next is model inverse properties for convenience, not necessity. For examples, has department, hospital has department, then belongs to hospital, then department belongs to hospital. Has diagnosis, patient has diagnosis, and diagnosis for patient, diagnosis patient. Both directions stored explicitly in file for query convenience. So inverse, how we have to define the inverse? It is like both way the relationship can be derived. So in that case, model inverse properties for convenience we have to make it so that it will be easy for reasoning purpose. Next one is default values are convenience, not some constraints. Examples is you could set examples like appointment status, where we say appointment status as scheduled on new appointment instances. So later which can be editable. Next, pick a naming convention and stick to it. This is very much important. Like every other database domain modeling, wherever the class in software industry itself, we have to adhere to a strict naming convention. Then next one is about use consistent capitalization. You must have seen that everywhere the first letter is capital. You cannot make it small letter. So adhere to that policy. Consistency, singular and plural, that is also. And use consistent prefix and suffix convention. For example, some methodologies prepend has a hyphen. Okay, some kind of has, then hyphen, diagonesis, something like that. Instead of that one, you can just stick to a property name has, then diagonesis, same word, but D will be capital and H will be small. So this is all about the naming convention, how the prefix and suffix should be there. You have to stick to a specific rule that is defined by the standards. Do not embed type words in names. Do not name things like patient class or hatch diagnosis slot. Right? So avoid abbreviations. Instead of cardiologist, you cannot make like cardio. And the superclass name inheritance in siblings names must be consistent. For example, since your file uses plain specialist name like cardiologist, or numerologist, rather than mixing in doctor cardiologist for one and radiologist for another, it correctly follows this rule that good positive example to show to the student that we have to make this consistent. And this is like for across all these classes. So here we understood, we just had a very quick revision of all the rules, and we are going to use these rules to build our ontology system. Before building, I have already kept this is ready, the ontology is already ready. So now let's come to the to understand what is what is everything is here. I have already kept ready the ontology, so let's try to understand what is there. So when I say that classes, the first thing is that we have to define the classes. So we should be able to understand the complete healthcare ontology systems. I have built this, the basic on healthcare ontology system, for this demo purpose only. You can extend it to the further levels by getting involved with the healthcare building ontology systems domain itself. By after understanding the complete process, sub-process, database, their glossary systems, the various kinds of documents, you can extend to the next level. So when we are building the classes, I have mentioned that, okay, admission, these are some classes: admission, allergy, ambulance, bed, billing. So if I go inside this, then here what you have to means, it's a subclass of owl.thing. So owl.thing, this will be at first, this is like the root directory. So if you want to add something, you can just click here and then you can add here something. And one thing is that you can add, and then this will be, this admission will be getting added there. And if you want to delete, then you can delete it here, delete the selected one. So in that case, I have came up with all these kind of classes, and the department is again divided into, these are all sub departments. And then person is like this: invoice, RAP, procedure, room, surgery, diagnosis. What are the different kind of diagnoses are diagnosed by, and subclass of diagnosed by exactly one doctor. So this is one kind of exactly when there is some kind of constraint is there. So we have used that owl to define this constraint, means diagonized by exactly one constraint. Then next is hospital, then laboratory test. There will be different kinds of laboratory test, blood test, CT scan, MRI, all this. Medical records, here also. Medications, different kind of medications, and then different kind of treatments. These are all classes. So next one is about the data properties. When we say data properties, these are these sets of all these, and root directory will be owl colon top data property. So inside that we have defined all these columns present inside. Data property means that is the columns inside the complete database schema we have defined. So from the classes, these are derived, some are, and some are like the actual column names. So if you say like this, here I have examples. In the similar way, you can add and you can delete, and this is like subclass. I have sibling property inside this. If you want to add some kind of sibling property, this button is useful for that. One example is that when we are defining date of birth, the domains is the person. Okay, date of birth belongs to person, and ranges is the XST string. That means what is the data type we are defining. So everywhere you have to be careful to define domain and range, and keep it in your mind that this is some manual activity. There must be some way to generate it in an automated way, but basically this is done in manual activity. Let's try to understand that. Next step, in next future session, I am also going to tell you how you can generate owl file, because everything after building this ontology, we are going to export this into .owl file, which we are going to use in our Python files for further next steps. That is that natural language to cipher query, every kinds of question and answering we can do in that session. So there will be using LLM to generate these owl files, not LLM, through some files that we are going to generate. So for each of these data, so each of these columns we are going to define what is the domains and range. This is first name, domain is person, and the range is string. We have already defined this. And what is next about the object properties? This consists of all the relationships. So administered by, here also domains. Domain vaccination is administered by the nurse. This kind of object property. Object property means it's a relationship. So here also diagnosis for patient, diagnosis, that is diagnosis for patient by, for the patient. Discharged from, patient is discharged from, range is discharged. And here some of these annotation properties are there. So what is that? Backward compatibility, some deprecated incompatibility, all this. And individuals, so here means some values we have added, like ambulance, this is some medicines, appointment, and then bed. So these are all individuals, those we have added here. So here the object properties for this, what are the different object properties, what are the data properties are here, then we can make it. So for patient EMA has diagnosis flu, has medical record, that his name is MR EMA. And data property is that, what is the data? Blood group, he has, the patient EMA has the blood group A+, and the first name is EMA and the last name is Wilson. So same thing for prescription 1, that contains medication aspirin, prescribed by Dr. Smith and prescribed for patient John. So all these informations we have to mention. So now all this, what we can say, this is our ontology is now final. built. Now let's visualize the complete ontology that we have built, and for that purpose what you have to do, you have to go to the Windows tabs and you have to click ontograph. Once you click on the ontograph, then you have to go to the owl.thing under classes, and there you have to come to this tab ontograph, and then this owl thing with all the classes, it will be displayed here. So if you want to see what is inside this admission, then you have to do expand. If you expand that one, then that is getting displayed here. Let's come, this is the admission and patient, and again if you do some expand, then here it is coming patient Emma, patient John, patient David, right? And how this beautifully, these are all the visualizations has happened. Then this patient is again how this is related to the medical record, then emergency case, then again this is the prescriptions. You can see all these kinds of visualizations, and how these are related to diagnosis, hospitals, right? So in this way you can do the visualizations, and you can correct if something you want to update or you have done it wrongly, you can update those things. Different kind of visualizations are possible. You can just click here and there, you can use all these buttons and you can get very nice, it's a kind of testing whether everything has been modeled correctly, that you can do and finalize this. After that, this now everything we have defined in this all file. What next we have to do? We have to export that into some to the file. So there it comes all file. We have to in this complete ontology that we can export that. We have already studied what are the different kind of serialization like total, then RDF XML, and the other is that JSON LD. Here .al means we will be using RDF XML. So here RDF XML syntax, okay, and that will be getting saved. It is already saved in my local system, and I have opened this here, healthcare ontology. So now let's understand this file, what does it does. Let me go to the top. Here what is, we have chosen this RDF XML serialization format, and the ontology is represented as XML version here. So do not worry that if the file looks complicated. We will try to understand how each of the section, XML sections, is written here. Very first line is the XML declarations. Okay, it tells the parser that this document follows the XML standard and specifies the encoding. Version is that, and almost every XML document start with this kind of declarations. Immediately after that, you can see like that RDF and RDF, small RDF colon RDF, XML NS namespace that we are defining RDF. So what is that net namespace? And we have for RDF, XST, RDFS, OWL, base, these are all kind of namespaces we have defined, and these are defined by this w3.org. So those we have reused only here. So every RDF, notice the, and these namespaces act like dictionaries. Instead of writing very long URLs repeatedly, we assign short prefixes such as RDF, RDFS, OWL and XST, so that these URLs will be used here. So if I say that RDFS, that means this RDFS, this RDFS refers to this RDFS, the long URL here. So it actually represents the full URI, that is the w3d.org 2002 07 all classes, all this. Next we encounter the OWL ontology part. Okay, here the element defines the ontology itself. Here we specify metadata such as the ontology IRI, the version number, is ontology RDF about, it's the, and the author information, comments, those some imports if required, those information we can also use here. And every ontology should have exactly one ontology declarations, and think of this as the cover page of the ontology. You can add comment, any kind of comment, version, author here. After the ontology declaration, the Protégé starts listing all the ontology components one by one. So here what you can see, this OWL object property, it starts with the first section usually contains the object property. Every OWL object property element corresponds to one object property we created inside the Protégé tool. For example, suppose we created one object properties named has department. Okay, so this is the first one, is that has department, and the Protégé generates an OWL object property element for it. Inside this element we can see the domain and the range. The domain and the range. The domain tells us which class can use this property as the subject. The range tells us which class can appear as the object, and in our example the domain is hospital and the range is department, and this means that the has department connects a hospital to a department. The next sections contains the data type. Similarly, you can check and you can correct if anything is wrong. You can correct it here, and then later you can update. You can upload this OWL file to your Protégé tool. So after updating, you can also use here file, and it's kind open, and then once you click on open, it will take you from your local system where you have saved this OWL file. You can upload that, the corrected one, and then you can do some kind of validation verifications whether everything is correct here. So once these object properties are complete, next is that the data property. Yeah, so this is one data property, and here also it's about the consultation fee. Here also some domain and range. That means domain is the doctor and the range is that XML schema. So here different from the object properties because they connect an individual to a literal value instead of another object. For example, a patient may have an age, name, blood pressure or the phone number, and these are literal values such as integers, strings, dates. Therefore, Protégé generates data property element for each data property. So there you can see like that it is a decimal, it is the string, it is the string, the way we had seen in Protégé tool. The next similarly you can verify all the data properties created. The next we will go to the class. Here the class definition starts. The first one RDF about person, and inside that one RDF OWL thing, that is the under the root. And then the hospital is coming, is a subclass of restriction on property. Every class we created inside Protégé appears as an OWL class element. If we created classes such as patient, doctor, hospital, department, etc., then each one appears separately. And whenever we define subclass relationships in Protégé, Protégé automatically generates RDF subclass of. See, this is RDF subclass of elements inside the corresponding class definition. Inside this hospital, it is like has department, resource. So this is the property and this is the class, has subclass of. So these are hospital subclass, all these are has department, these are getting created. Okay, so department then contains ward, all these are getting created. If we have added any kind of labels of descriptions inside the Protégé, then it appears with the RDFS labels and comments, any kind of yes. So these are some human readable annotations, and they do not affect any reasoning but make the ontology easier to understand. So if you have created any individuals, we have created some individuals here. These are some individuals, and those will be displayed after that. So these are classes are continuing class. These are some named individuals: hospital emergency department, named individuals cardio department. So each individual has an RDF type, RDF resource, RDF type. This is RDF type resource, then has department, RDF type resource, cardiology department, indicating which class it belongs to, and along with properties, values that describe the relationships or the literal values. So it is important to understand that this XML is simply one serialization format. The ontology itself is not XML. OWL is an ontology language, and RDF is the underlying graph model, and RDF XML is only one way of storing that graph. The exact same ontology can also be saved in turtle file, JSON LD, ntriples, trig without changing its meaning, that we have already discussed before. Now that we understand how Protégé stores the ontology internally, we can use this OWL file in different semantic technologies. We can load it into Apache Genafosky to execute Sparkle queries that we will see in next session. We can import it into GraphDB or StarDog for reasoning. We can parse it using RDFlib in Python. We can convert it into Neo4j if we want to work with a property graph. So the important takeaway from this session: the ontology Protégé is the ontology editor. OWL is the ontology language. RDF provides the graph model. RDF XML is the storage format. And this XML document is simply the machine readable representation of everything we build visually in Protégé. So let's see, in the next session we'll learn about Apache Genafosky. We have generated that OWL file. Now the next part is that how to query it. So for that we need Apache Genafosky, where we have to write various types of Sparkle queries. The Sparkle queries we have already covered in module 6. So this is the hands-on practical sessions of understanding, writing and executing some Sparkle queries. So for that you have to download the Apache Genafosky, and I have, for my Windows systems, I have downloaded 5.3.0 that is compatible with Java 17.0. So before that you should have your Java version installed in your system, and based upon the compatibility you have to download a compatible Apache Genafosky version. So mine is like Java 17.0 is compatible with Apache Genafosky 5.3.0. So I have used that one. You can do as per your system's JDK version. So once you download that one, this will be getting downloaded in the form of zip file. I have unzipped that one, and then you can check what is inside this. So Fisky server is there, some bat file, this is the bat file is there. Now come back to your command prompt. You go inside this, the completely CD, you have gone inside this, the complete file, complete folder here, and then run this bat file, this Fisky server bat file. So Fisky server.bat, then we will be getting all these informations, right? Everything is 200 okay, everything is running fine. Now you have to open localhost 3030 in your system. So once you open that one, then it will open one. First is that create dataset option, it will ask you. So just you have to give the dataset name, and then you have to come here to the add data section. Dataset graph name, keep it blank, no need to put anything. Then files to upload. So if I say files, what kind of files? Then you have to upload that OWL file that you have downloaded from the Protégé, okay, or after some kind of XML in that RDF XML, if you have done any kind of update, that you can reuse. And then upload, one upload button will be coming, there you can upload. Now this tool is having your data set. Now the next step is to run some Sparkle queries. So come to the query tab, and then here we will be running some queries. So this is very easy, similar to some kind of SQL queries. Just you have to understand some kind of where this is coming, question mark, and how these fields are there. Before that, we have to always keep this prefix. What kind of these attributes, RDF and examples we are going to use in our Sparkle query, those prefix we have to mention, because what is that prefix? RDF, this RDF itself is such a long text, okay, we cannot use that such a long text and then column type. So we have to use RDF prefix RDF and this complete URL. So now I have already kept few queries here. Now come back and try to understand. The first is that some kind of select queries. So what is the select queries? The patient. Here the most frequently used query is the select queries and return some kind of tabular results. So what it does is that it is like the patient, return the patient where the patient RDF type is patient. So it will return all the patients stored in our OWL file. So if I ask you one question, which Sparkle query returns a table, then your answer should be select. Now select question mark patient. Always remember that when you are retrieving a specific class informations, any information, class, whether attribute, data property, object properties, before that you have to put one question mark. Where again same question mark, RDF type, EX patient. So prefix EX means it is of healthcare hospital.owl. From there we are retrieving. Okay. So if I run this specific query here, let's run this. I have to include the prefix also. Then I got 3 patients. Those are present in my data set. Describe query, and it returns all known information about a resource. So if I write describe X prefix that I have given about the patient John. So here it says that patient John, RDF type, named individual, blood group, all informations about patient John, covered by insurance policy A, first name, follows care plan, has billing, all this information it has. Next, if we try to ask some kind of query, and that should return some kind of true and false. So that can be done through ask query. So if I ask this specific information, whether the patient John belongs to, where the RDF type belongs to a class patient, then it is true. So it should return true. The next one is about where clause that contains any graph pattern. So what I am trying to run, graph patterns means patient has diagnosis, specific diagnosis. So for this, here select patient and diagnosis, where the patient has some diagnosis. So here these are the 3 patients we had seen, and each patient is having what kind of diagnosis, these are getting displayed. Now next one is that filter. So that restricts some kind of knowledge. So if I say patient age, where patient age filter with greater than 60 years. Then here I am writing there is no data available. If I say that less than, greater than something, is there any value? Greater than 30. No, it is not there. Okay. So if I write something greater than 5, then I don't have any kind of age information provided in this ontology. You can update the age information, and then you can run the query. So that is a homework for you. You can add age information, and also some DOB, date of birth, is already there. If you see, then in that case you can see data properties here. You can also put some kind of date of birth information, and then you can run the query by applying this filter. Age is not there, a column I have not added there. Next, about optional, that returns some optional data. Select patient phone, where patient, if a patient has no phone number, then patient is still returned. Right, you can run this. I will share all this Sparkle language, Sparkle queries. You can run all this. Then the next one is about union. So what it says, combines multiple patterns. Then here what it says is that returns both patients and the doctor. So these are all patients. Next one is about bind query, that creates calculated variables. Here I have used all the levels. I want to display that in uppercase data. So in that case, what I have mentioned, that class and the upper level. So all these classes, this is a class RDFS label. Label should be displayed in uppercase. So if I run this one, then I am getting all these classes named as in the uppercase, where in the Protégé tool only the first letter is in uppercase. The next one is about the values, that supplies some predefined values. So only searches this department. When if I saw that predefined values, cardiology and neurology, then it will search only these values and display it to you. There is no department. Doctor works in this department. Okay, so departments are there, but there is no doctor assigned to these departments. You can add some data, and then you can rerun this query. Next is about order values. So if I say sorts results, so next is about order by patient, and then order by descending, means patient name. For examples, if I run this, okay, David, Emma and John. So these are like in patients' names are getting displayed in alphabetical order. Then next one is about limit, that is limit 10, and some kind of aggregations queries. Let's see some kind of aggregations queries. For examples, if I say count, how many total patients are there? Then it will show that it is 3 number of patients are there. So similarly, I have displayed count. You can use sum, average, mean, max, group by group, any group concat. The next is about group by any specific uh, variable. So what it does is that group by department. There is no doctor, group by department. And then some kind of having clause. So having clause, if I say this, these are then it says that there is no doctor assigned to any specific department. So I have again on top of that one I have put that having count doctor greater than 2. So I'm not getting any specific data for that one. You can add data into our ontology and you can run these queries. How to add data in our ontology, that we can do through the Protégé tool also. Through the instance you can keep on adding. And also we are having one Python file, there also you can add values. That we will be learning next. So next important part is about the property path. So what it says, one of the most powerful, this is Sparkle features. Here what happens now, multiple relationships become one expression. So what is property path? A compact syntax for traversing multiple relationships in a here no data is also available. Some then you can say some kind of subqueries. Let's write some kind of subqueries. These are these path operators. These path of operators are actually, it is like you can give some one step and then 0 like this. If you want to execute this patient extracted by, this is one step, 0 or more. EX part of star, that is hospital department, where a single department is part of 0 or more hospital. Then when more is there, then it's a star mark is there, and 1 or more, then the plus mark is there. Department belongs to 1 or more organization, then plus mark, single plus mark. Optional means this is a question. Alternative means single piped. Inverse means that is the square top power queries. And then subquery. When it comes to the subquery, it is like queries inside another query. If we have any data here, here also no data. And then some filters, these are some advanced filter not exist, minus insert Sparkle update queries, and some kind of insert data. Let's try to understand this insert data. How I can insert data through Spark query. So update successful. If I write it here, it is already added. And then delete data with the delete. So similarly, we can also put some conditions with the where clause. That also you can delete. So delete where, this also you can perform. So these are some of the Sparkle queries which we learned here. The next step is about coming to, we have learned so far we have learned about the ontology. What is ontology? Representation, knowledge representations, then various parts, how we can build ontology with a Protégé tool, how we can execute Sparkle queries inside Apache Gina-Fusky. And now next part is going back to our Python lab files. There we will be updating. First thing, we will learn how to create one OWL file, generate one file and add data into that one, and how we have to build one web applications, and through the web application, through natural language queries, we will be getting all these queries result there. And all those data, those will be getting stored in one kind of graph DB. So I have used Neo4j for this, which is a property graph which is free for at least this community user, that is free. And for that I have used Neo4j desktop. And how we'll be going, let's see that.